Hi, welcome back to video tutorial on AIOS. This is a part 2 video of our previous video cluster node block onboarding policy of control. So in the previous part 1, we saw mainly what is cluster controller gateway and what all different components are there in the so APIs are there in the cluster controller gateway. And then we saw the cluster controller and what all different blocks in the cluster controller, components in the cluster controller, and what all APIs are available in the cluster controller gateway that we can utilize, and how to create a Kubernetes cluster and how to join that cluster into a AIOS. And also then we created certain blocks, deployed a blocks on that cluster. Then we did some inference on the cluster by running an inference server into the cluster, and then we did a reassignment by calling the management API. In this video, will be it is mainly about node onboarding with policies. In the previous video, there was no policies when node is cluster is created, but here we'll be talking about more about policies during the node onboarding, and also certain policies with the blocks. So prerequisite is you need to check the part 1 of our video to understand the APIs that we'll be using in this video. And also you need to have a prelim knowledge on how to deploy a block and all. So please check the part 1 video of it. So here we need to have one cluster already being available in the Kubernetes. So which I created already in the previous video. One cluster I have created, and that is onboarded in the AIOS. That might have worker nodes or that may not have worker node, doesn't matter. And then I want to onboard a worker node into the cluster which is already available in AIOS. That's what we are going to show. So for that, you need to have a worker node ready with you. Let's say it could be an GPU node or CPU node, anything. So that worker node has to be ready. And to make it ready, you need to install the script. This is available here. So what that script is basically like some bunch of apt-get installs, then containerd, and some configuring certain containerd files, and the bridge network creation, and then installing the binaries of the Kubernetes. So that you need to install first. Then also you need to install the NVIDIA driver if it is a GPU node machine. So you install the NVIDIA driver, then NVIDIA container toolkit. Then to install the NVIDIA container toolkit, you can follow this particular web page. And once it is done, that's it. So you can leave the worker node there. Then important is once node is joined, you can replace the toml file. So in the previous video, we have showed that there you need to replace a toml file, but now don't do it. Once the node is joined, then only we need to do it. So let's get into the policies of control. So in AIOS, lot of policies can be written, which will give us a user a lot of control. So one such control we'll be exploring now. So now the policy of control at gateway and at the cluster controller. In the previous video, I told like the gateway is under control of a network owner. So whomsoever creates the network, the AIOS network, that guy will be responsible for putting any policies in the gateway. Whereas the cluster controller, the cluster whomsoever is the owner of a cluster, he will have the permissions to put the policies to the cluster. So which is a cluster controller. So let us write one policy which is a add node policy, which will kick in whenever a node is getting added to the cluster. So this policy will be running in cluster controller gateway as well as in the cluster controller. So let us explore what is there in the cluster controller gateways policy. So basically in this policy, we'll be checking minimal things only. Like say since it is under the gateway is under the control of network admin, he can impose certain small restrictions or smaller rules. So he or she can have their own rules. Let's say a minimum CPU requirement should be this much, only these GPUs are allowed. So those kind of rules they can put. So whereas in cluster controller, the cluster admin can have a little more refined rules, like the rules that is makes that particular cluster's life easy. Like say the cluster might require only the nodes with are like 8 vCPUs. If it is less than that, the cluster controller is not interested, the cluster admin is not interested, so he will not allow to add that particular cluster node. So similarly, several such the control he can have, the cluster admin can have. it's not just about the minimum, it can be about the maximum also. Let's say the cluster admin wants to put a rules like we need to have maximum of only x number of nodes or x number of GPUs. There also they can put that kind of restrictions. So and also sometime we can put some restrictions on the KPI side also. Let's say the node can be joined only when let's say the vCPUs of a whole cluster is occupied by 50% or 30% or 70%, or like if you're adding a GPU node, the GPU utility of all the GPUs in this particular cluster should be this much. So that kind of a restrictions on a KPI also we can put, the cluster admin can put. So we'll explore one such policy. So the links are provided here in this particular notebook itself. So here policies, gateway policy. So in the gateway policy, the structure is like there will be a code folder. The code folder will have actually function and requirement, and other files are basically for registration and uploading the file. Let's say there is a gateway registration policy .json file. This is basically an registration file. This is a bash script for it which uses this registration file, and there is a upload.sh which will basically upload the zip file created. I have already created the zip file. Basically I'll zip this whole folder into a zip file. So that zip file I have to upload it in the upload.sh, register it. And if you want to know how the policy, what is the registration's content, so you can always run a get.bash. And if you want to deregister the policy, let's say you have done some modifications and you want to deregister it and re-register it, then you can deregister it and modify the content in the JSON file and do the registration. And also here is a test script is also available, which you can run the test the code that you have written here. So let me explore the function.py in this. So as I told, this is a gateway policy, right? So the network guy is putting some minimum requirements. So what are those minimum requirements? So I'm checking right now only the static items. Let's say minimum node CPU. So when a node is getting added, what should be the minimum CPU that node should have? By default, there is a 4 number. Minimum node memory. What is the memory of the minimum memory of the node? RAM basically. Yes. What is the storage? And similarly, required GPU model. This cluster will allow only the GPU model if they are of this category. It could be NVIDIA T4 NVIDIA. Let's say you are the cluster admin is not interested in GPUs which are lower than the T4 kind of a category. They can put only the upper required models. We can also say this GPU require. You can also create a variable like this where GPU should not be added at all apart from the required GPUs. Minimum GPU memory. So what should be the minimum GPU memory? Like whenever you are trying to add a GPU, whether 4 GB models are GPUs are fine or not. So those kind of restrictions. Allowed tags. You can talk about, like say a node has some sort of a tag. You can allow or disallow those tags. So minimum network interfaces. How many network interfaces has to be there? 1 or 2 network interfaces. What is the minimum transaction, TX and transmission and reception bandwidths required? So those kind of restrictions this network admin is putting it. So and here basically we are just checking it. So here basically we have two functions, two main functions most of the time. One is management function and one is a eval function. So in the eval function, you are getting this kind of inputs. So one is node data, cluster data, and cluster metrics. And I have created two functions here, which will just basically checks the nodes data only without any information about cluster data and cluster metric. It takes the nodes data and validates the nodes data. Here it is about validation about node hardware, which is basically let's say validation of nodes hardware. Here you are checking the vCPUs, memories, storages, whether they are reaching beyond the given the parameters. So if they are so, then we are returning a false. If they are not, we are returning a true. So at the end, all these are checked and returned true. If they are satisfying it, we are returning a true. And similarly for a tags. So if they are in the valid tags, then we are returning a true. If not, we are we are returning a false with an error message. So this is being checked here. Yeah, this is being checked here. So whether if it is not valid, so then we'll return a allowed equal to false. So basically this policy has to return allowed true or false. It has to return, and input data. That input data can be a modified content or the input itself. So generally whenever it is true, we'll return the input itself. Whenever it is false, we'll return the modified content. So this is a policy, simplistic policy. You can make complications in it. So similar to this, let's go back to the cluster controller, who is a cluster admin. So for him also there is a similar structures are available. So let me just go to the function.py. So in the function.py, these are the same thing I copied from the network admin. Only change one change here. I'm keeping like two parameters are changed. One is a max node per cluster and max GPUs per cluster. Uh, so and also one more parameter is threshold cluster vCPU utilization for add node. So this is basically based on the KPI, the cluster metrics. I'm calculating what is the vCPU of the whole cluster, what is the utilization, whether it is 10%, 50%. So that kind of checks I'm doing here. So by default 50%. So basically when clusters vCPU utilization is beyond 50%, then only basically node can be added. So that's what it is doing. So similar to those functions are here. And so in the cluster capacity, I have added the KPI based check. So here I am taking the cluster metrics. In that cluster metrics, there is a vCPU key. So from that key, I am taking a load 5-minute average, and that I am doing a percentage calculation by dividing the load 5-minute as well as the total number of cluster vCPUs available in the cluster. So then I'll get a percentage, and I'll check that percentage. If the percentage is less than this supplied parameter, I will return false. If not, the true will be returned. So this is the true return. So return. So next validation of tags will be there, and those are other things are similar. And I forgot to explain you the management function. Management function is basically updating the minimum resources, or update cluster limits, or tags, or network requirements, or GPU requirements. Such kind of functions are there where you can call the management functions to update any of the parameters that is already running. So this is an again a simplistic add node. So you can make much more complicated by using the KPIs. You can write, you can think about any complications you want to bring in, and you can bring in. And this is just the add node. So whenever node is getting added, these policies will be called. So I have written the policies, and let's say I have uploaded, and what are other policies we have. So we, in the cluster controller gateway, we have several policies like remove node. Whenever you are removing a node, what needs to be done? Add a cluster. Whenever you are adding a cluster, what you need to do? Remove a cluster, add a block, remove a block, so update cluster, scale block, block management, and cluster management. So these all are the policies we can write, that is under the network admin. And similarly, we have some more policies like remove node, remove VDAC controller, because VDAC controller is a part of the cluster controller. So when we are trying to remove a VDAC controller, what needs to be taken care? When you are adding a VDAC controller, what needs to be taken care? Let's say you are trying to add a VDAC controller in one node, but that node is under load, so you should not add into that particular node. That kind of checks you can do. When is there any node which is less than let's say some say 80% utilization, CPU utilization, or a disk utilization, or a RAM utilization, then only we can add any further VDAC controller. So such kind of rules you can put in this policies. So you can write off your own, because the policies under the cluster, the cluster admin or network admin, so they will control their respective stack in the AIOS layer. So what is the process? So you for the onboarding these policies, they are exact same. Like first you need to register the policy in the policy system of a AIOS. So you have a function.py, and a directory is there. So you need to zip that directory. Then you can this is the folder structure, and zip that, and then call the bash upload.sh present in that particular folder. So it will upload this zip file into a place where the policy system can pick it, and then register the policy. Now this is just the policy registration. You never told this policy is for a gateway, or this policy is for a cluster controller. So this is for if I run this command, it will upload the the zip file to of a gateway, and if I run this command, this will register the JSON of a gateway for a add policy add node, so which I have already done it, so I'll not run it again. So you can and similarly for a cluster controller for add node uploading and cluster controllers add node registration. So let me run this because it has several endpoints in it which will be using it. So then we shall see like the gateway APIs for a pre-check policies. First, I have to though I have registered the policy into the policy system. Now I need to add that policy to pre-check policies of a cluster controller gateway. So this is the API where pre-check policies slash update is the API that you need to call, and in that I have to provide the add node because it is an add node policy. If you have multiple policies you want to onboard at once, you can do that, just like you create a remove node or any other policies you want to bring in, right? So this API you can use it. And in the add node, so there are two para things. One is two keys, policy rule URI and a parameter. What is this policy rule URI? It is a the policy name of the add node. So this policy rule URI, you can check it in our JSON file. So let me just show you that. Yeah, so this JSON has a gateway add node policy 100 stable. So that's what I'm trying to add it. Gateway add node policy 100 stable. So you can check this JSON file, what are its contents. So it has a metadata and then policy input schema, policy output schema. So what is the input data? Like in the policy, we saw that there is a function, right? So in the function there is a eval. So eval function has few things, parameter and input data. So what should be the structure of this input data is defined in the input schema. So it should have a node data, cluster data, and cluster matrix. So it has a node data, cluster matrix. So what is its schema? So it is given like object. So again, I'm not going in detail with what all content of that object is. So I'm just mentioning object. So if you have let's say few keys only in the object, which is a dictionary, you can mention it. So but this object will have so many contents, so that's why I have not given full details about the node data. Similarly, cluster data, again object, and I have not given the complete details. Cluster matrix also, it is an object, I am not given a full detail. So who will put these details? So the AIOS will take care of dumping this data to the input data. So you are not doing anything with it. So input data, so AIOS code will take care of dumping those keys. And similarly, now it's the input schema, then it's the output schema. So what should be returned? So there is has to be an allowed key and there has to be an input data. So that's what we are returning, allowed and input data. So allowed is just a boolean, and input data is again an object. I'm not mentioning the structure of that object again. Then policy settings schema and policy parameter schema. Right now setting schema nothing is available. In the parameter schema, so allowed tags, minimum node CPU, minimum node memory, all these details are available. So individually what all they say, allowed tags is an array, minimum node CPU is an integer. So that kind of details are available in the parameter schema. This schema is nothing but just the structure of it. So the actual default parameters you need to send, right? Let's say when I'm calling the this, I'm not sending any parameters, so then something has to be there as a default. So that's what this policy parameters and policy settings are. So if you are not sending anything during the registration or calling of this function, then by default it is a fallback parameters are here. Allowed tag is, there can be a 4 like a GPU production, something like that, allowed tag. Minimum node CPU are 2, RAM is 4 GB, node storage is 24 GB, something like that. Fallback numbers are there. So this is for policy parameters and policy settings. And in management command schema, so what all commands are there? Update min resources. These are the 4 functions are available. Update GPU requirements, update tags, update network requirements. So these are the minimum 4 functions are available in the management. So that's what we have given in the management command schema. So now so let's say now I'm this is the parameters that I want right now for my network. So this, as this is a gateway policy for this network, I want to give some minimum numbers. So here right now I have given a transaction and Rx bandwidth as -1. The reason being is, um, since we are trying to deploy it on a GCP cluster, we were getting 0 as a sometime for a TX and sometime for RX. So that's why let's not you know let's not I mean, we should make sure that the nodes should be added. I'm just keeping a -1 so that we don't do a proper check for these two items. uh, so minimum node CPU is 1, minimum node memory is 2048, and minimum network interface is 1. So these are the parameters that I'm configuring it right now. So so once let me run this. So you can run this any number of times, so it will just do the updates only. Yes, it is updated now. So let me just to get the what all policies are available for in the cluster. So you just have to give precheck policies dot get. It's a get API. So if you do that, it will show you what all policies are available right now. Let's say if you have a remove node or some other policies, that will also get displayed here along with the add node. So now next thing is, I just want to show you certain commands of kubectl that I will be needing now. So these kubectl commands we need to run in management servers. So management servers are under the control of cluster sorry the network owner. So in the management server only we should be able to run this commands. So I'm trying to get the pods of a namespace known as service, and in that I'm trying to get one cluster controller gateway pod, and I'm trying to check the log of that. So we can check in Kubernetes dashboard also. Right now I will not be showing anything with the Kubernetes dashboard. I'll be using the kubectl command only. So first we'll check what all pods are available in the management server. Yes, there is a cluster controller gateway. So this is the pod that I am interested in. So let me get the next command. So this is the pod. Yes, this is the same pod. So let me just try to get the log of it. Yes, these are like previous runs log, so I'm not so interested. Yeah, so let it be there. Okay, so this is the a pod of a cluster controller gateway. So now I'm going to run a dry run. So this dry run is basically not exactly adding a node. It is just the checking of the policies, whether the policies are working fine or not. So that's what we are calling it as a dry run. And the input to the dry run, like what is the URL? Precheck policies add node slash dry run, and you need to give a cluster ID. So without the cluster ID, we will not be able to the network will not be able to check to which cluster this is supposed to get added. So you need to run a dry run here, and in the dry run data, it is about network data. So this sorry, the nodes JSON. So how this nodes JSON structure I copied here, so that you can get it from the sample JSONs here. So you have a lot of sample JSONs here. That is the node data here. So similar structure, I have copied it and I have put it in the file. So right now I'm expecting say my there is a minimum network interface. What are the minimum things? Minimum node CPU is 1, and transaction. Okay. So okay, let me make it as a 5. So I just want to show you a failure case of it. So I want my dry run to fail. So right now what I have done is I have updated minimum node CPUs to 5, and in my dry run I'll give CPUs to, let's say, 3. So vCPUs count I am giving as 3. So this is basically a nodes metadata. I'm just modifying it. That doesn't matter. This is a dry run only. So let me run the dry run. So when I run the dry run, I'm getting directly allowed equal to false without any other keys here. So insufficient vCPU required is 5. So why? Because the cluster controller policy has executed, and it has identified that the CPUs that we are supplying for a dry run or actually onboarding, it is not sufficient. So this is what the policy update would be. Somewhere here it will be there. So I don't know, policy evaluated allowed is false. You can add more verbose so that you will get each and every details. in the function.py of a gateway policy. So now let me change it back to 1 so that I'll go to the next policy, the add node policy of a controller. So if I run this now, it will get executed true. I'll show you that. Yes, it went through. So it went through, but you are seeing one extra key because the gateway has succeeded. Then it will give to the controller. So it will go to the, it will talk to the cluster controller, but cluster controller evaluated false. Why? I will show you that. So that's why the final allowed is false. So if you are getting this cluster response, it means it has gone through the gateway and then it talks to the cluster controller, but cluster controller has said no, it is not possible. So that we will check. So anytime you want to remove the added policy, right? So for this itself, like it's the same pre-check policy update and make it empty for the add node. So if you do that, uh, by default there will not be any policies for add node. So if whenever someone is trying to add the node, it will not get evaluated. I mean, any policy, since no policy is there, there is no control over. So it will simply add. It will say yes to it. Now let us see the cluster controllers API for pre-check policies. So similarly, we have like same, it's the same API, but at the end I need to add the cluster ID to it. So cluster ID equal to the cluster ID, which is a GCP demo, something like that. So here, since it is a policy of the cluster controllers admin, so I have given some policy here, min node CPU is 4 GB is required, something like that I have given here. And one thing I would have changed here is max node for okay. So let me just show you this. So one thing I have kept here is the KPI based policy, which is like 50%. If the cluster utilization is 50%, then only the node has to be added, is what my requirement is right now with this policy. So because of this, a policy should not be added. Let us see how it goes. Yes, I have set up the the policy right now. The policy is added to the cluster controller. So let us check what all the policies are available in the cluster controller. It is also same. So you have, it is a get API. So you have to get and give the cluster ID. So you will get what all policies of those clusters cluster is. And to know similarly, like how we saw the logs of the gateway, right? So to check the logs of the controller, so you need to go to the master node of your cluster. So this is my master node. So I have one more terminal here. This is my master node. So let me just put the command here. So there are like 3 pods are available in this pod, GCP demo cluster controller. In this pod there are 6 containers and rest all has one container. And let us check about this guy. Sorry, we need to check the membership server. So let me check kubectl logs. Controllers is the namespace. And okay, so let us check this policy. So this the membership container is responsible for evaluating your add node policy, because it is at the node side. Node is getting added and the membership pod will take a hit. So let me try to run it now. So it is like it has a 8 vCPUs and I have not modified anything. So let us see how it goes. Yes, allowed is false. The reason being is, let us see what is the reason. So add node policy evaluated false. Any other extra informations, initialize, okay. So I would have not kept any extra metadata in the log printing. So at the end it has given a, okay, so cluster description, okay, cluster node limit will be reached 5. Okay, so let me just make it 7 or something. Okay, cluster VCP utilization is below the threshold 0.5. Current load is this much and percentage is this much. So that's why it is not able to allow the load, the node to be joined to the cluster. So that's why I'll try to reduce this utilization to very small number. Okay, So now we saw the how to the dry run API is also very similar. Like I just have to add at the end the cluster ID only, nothing else. So it's the same API for dry run in the gateway as well as into the cluster. It is the same API because at the end the node will be added to the cluster only. So the endpoint is not this. I mean it is the same. So now we did a dry run for add node policy in the cluster controller also. So any point of time, if you want to remove the any policy that you have set up, so this is the again same API pre-check policy update cluster ID equal to this and node add node equal to empty. So by doing empty, no policy will be evaluated when you are adding a node. Okay, this is about the policies that we have control over, one for a control for a cluster admin and one for a network admin. So similarly, we can write all other policies. So we have given a basic code only to you. So now let's say I want to onboard a node. I have one more node with me, which is like a GPU node 4. I want to onboard this into my cluster. Right now that is not available here. GPU node 1, 2, 3 are available. So I have not given a GPU node 4 yet. So to onboard that into cluster, so what all we need to do? So so generally then no, adding a node to the cluster is a manual process. So we to avoid that manual process, we have created on binary membership client, so which will help us in onboarding process. So please check prerequisites, yeah, that we have checked already, and copy the kube config file from the master node, which is like generally you will keep this here like so that you can execute any kubectl commands in the master node. So from that master node you need to copy it to the your node that you want to add. So once you do that, copy the binary to the node you want to add. So this is the binary that we have. So this binary is available again in the node onboarding cluster setup. So it is in the part 2, yeah. So membership client, it is here binary. So this binary you need to copy to a to your node, because from that node only we will execute a command which will copy the it will talk to the Kubernetes cluster and joins the node. So copy the binary to the node you want to onboard, give the execution permissions to the membership client, and run the binary file. So if you run this, you will get the help, what all the functions it can do, what all parameters it has to take, all those things it will display. So and before running the membership client, you need to do this activity. This is a one-time activity only. So you need to get the SHA-256 hash of your CA cert file. This cert file will be in the your control plane or a Kubernetes master. So from master node, you need to get this SHA of that. So you have to run this command. It will print one number, and that number you need to put it here. So once you run this, what happens is this this API is basically about the updating some metadata of a cluster. So here global cluster DB I'm talking, doing a put operation here, and in that clusters I'm choosing one particular cluster ID, and in that there is a config.cert hash is one field. That field I'm updating. So you need to copy this and you need to put it here in your hash and then run this. So for me right now I have done it already, so I'll not be doing it again. So once you do it, next step is use the binary. So now you can onboard the node to a cluster using binary. The command to onboard node to a cluster is this. So sudo is required, a membership client, and then action you have several actions: join, dry node, add, dry run. So I'll just show you what all yeah. So there is a dry run add, dry run remove, join, and remove. These are the 4 actions it has. And then API, this API URL is about the cluster controller gateway API. And then hyphen GPU is for if the node is GPU, so you need to say this, hey, this is the GPU node. And then cluster ID, what is the cluster ID you want to add? So because this will be filled at the end to a API that we are talking here. So the API that we tried here, right, for a dry run and all. So these details were needed. So that's why we are giving those details. Then metadata. So one thing you would have observed in the nodes data, let me just show you that. So in the samples JSON in the node data, there is a field known as node metadata. So you can give anything. There is no hard only these keys has to be there. You can keep any of your key value pair there. So if you want to keep any key value pair there, so for that I require a JSON file from your side. So that's why I'm a pass to a metadata JSON and tags, a comma separated tags you want to give, whatever the tags you want to give, that you can give here. So when I run this particular command, so this will since it knows this cert hash, it will it will take the certificate from this. Okay, it will try to fit the cert hash from this particular cluster ID, and it will take care of talking to the gateway, and then it will try to do a command, a join command. So let's try to run it. So I have tried executing the command already. Okay, so it has executed its requirements. Now yes, the node 4 is joined. So that's what we are seeing here. And so now after doing this, we need to do one more important thing, which is very, very important. Once node joined, you can replace the toml file to etc toml config.toml. So in the previous video, in the cluster setup time, I would have given those commands. So let me just go to the cluster setup guide. This is the path that we need to uh, copy that toml file. So where is that toml file in that node? Yeah, this is the config gpu is the file, sudo cp. I'm replacing it, and then I need to do the restart of the container D. Okay, container D is restarted now. So let me close this. Let me come back to the actual one. Okay, so now that node has been joined. So for a anytime anything you do manually, let's say you removed a node manually, or you updated the hard disk of a node or something like that, right? So it is better to you increase the hard disk, or you change the RAM, or anytime you did anything manually, it's always good to do a sync cluster. So let me run the sync cluster command. So here it's there's a cluster sync URL, and it will use that, and it does the sync run a syncing. So it has done a syncing operation. Now this commands I have already used it. So kubectl node has been added here. To get the cluster details, you can use this API where cluster read, and you need to provide the cluster ID, and you are talking to the gateway URL. So let us run it. So you are seeing all other details, and what I'm interested is the nodes. Here there are count is 4, and this is a master node, and this is a worker node 2, which was from the previous demo. And this is also one other node that I already had in the cluster, and this is the node that I have joined. So it has a 2 GPUs Tesla T4 again. So this one is the cluster reading, and if you want the metrics of the cluster, again I'm using a gateway URL here, cluster metrics, and I'm giving the cluster ID. So this will fetch the again metrics, and what I'm interested is node metrics. Here you are seeing worker node 3 here, and worker node 2, and this is the master node, CPU only node, and this is our fourth node that we have added where 2 GPUs are there. So now we have added the a node using a membership client, binary client, and once the node is added, now we can create a blocks in it. Before creating a block, I just want to show you one more policy of a block, which is known as health check policy. So to know more about health check policy, you can click on the link here. This will directly take you to the health checker policy. What this does basically, so it basically checks the health of the block at fixed intervals, and in that policy basically you will get input data. In that input data, if you have already one key known as health check data, so that health check data dictionary, it has data like this with respect to the instance. If this true and false means, like if true is nothing but basically the health of the instance is good, and false means the health of the instance is not good. So with respect by reading this data, so you can say okay whether this instance is good or not. If the instance is not good, then we can do something, meaning either we can move the instance from this node to some other node, or we can basically reassign. So that's what I'm trying to do right now. So earlier we were in the previous video we did manually by calling the management API of a resource allocator by calling the reassignment, but here we will call the reassignment with the help of a health checker policy. So the code I'm going to show you. So yeah, that's what. So if it is not healthy, we'll call the reassign API. So we will call the reassign API, but with the help of health checker policy. So let me take you to the health checker policy directly. So here again, it is all like you have a JSON file, registration file, deregistration file, getting the registered policy. I have already zipped the code here, and you have a testing script as well. So and also you have a upload file. So what I'm interested in function. So in this function, you have eval function similar to what you saw in the documentation input. In the input, the input data, you have a health check data. So the that dictionary will have block data and cluster data. In that, I will like loop through the health check data for each instance. And if it is not healthy, so I'm just having a counter basically. I will not immediately take action if the instance of the health is not good. So I'll have a counter, and if the counter is going beyond some threshold that I have defined, the threshold can come from the parameter. So that's what the threshold is here. Yeah, the failure threshold, by default it is 3, and if it is going beyond the threshold limit I set, then I'm calling on function here called reassign policy from the allocator. So what this function does is basically calling the controller reassign instance, and I'm just giving the cluster ID and the instance ID here, instance ID that is down, which is not good in which is not having a good health status, block ID, and extra data. So extra data here is empty. So in the previous video, if you don't remember, like I'll just show you that. In the previous video, we provided the allocation data. In the extra data, we provided allocation data. We were forcing it to run it in this node only with these two GPUs. But here we are sending an empty data. The reason being is I don't want to manually, because when you have so many servers, you don't know which server manually to assign, right? So you will not be in a direct connection with okay whether if this instance is down, you move to this. You don't want to do it manually. So to make a automation here, I'm just not sending anything. So let the policy that the resource allocator decide. So I'll do a request.post to the gateway using the gateway URL control reassign instance and cluster ID. So it will take care of reassigning. So it just does a call to the reassignment policy again and nothing else. So after that it resets the counter because it has reassigned already, and it moves on. So we have management command here, like just basically to get all the status details here, or reset the counters, or reset instances. These are like functions that you can do anything in this management functions. So this is about the basic health check policy, and yeah, so you can upload the file, the zip file, and you can register the function, which I have already done it. Then let us go to the resource allocator policy. So in the previous video, the first part of the video, where we showed a very minimalistic resource allocator, but in this case we are going to do a little more complicated stuff. So here you again you have the structure is same as the other policies. You have all the register, upload, get files, deregister files, JSON files. So my intention is to show you the function. This function, it has again a eval function where it receives the input. In this input, basically this is a resource allocation. So whenever a block is about to resource allocation policy will select the node and GPUs. So this resource allocation basically has 4 actions in it. One is dry run, allocation, scale, reassignment, which I have already explained. So right now what we are interested in reassignment. Whenever a reassignment call comes, instead of taking that this manual data like allocation data, right now I have not kept any, I'm not taking any allocation data. I just created one function here which will take care of choosing the node that it wants. So let me see what is there in the handle reassignment. So it takes the payload, it takes the context nothing, not of our interest. So payload is what is of interest. So this payload has all details. So what all details are available in the payload? So you have block, cluster matrix, block matrix, healthy nodes, instance ID, pod name, all those details are available. This data are put by the AIOS itself. So here what I'm trying to do is first try to extract the resource requirements. So I know that whenever this block runs, when this instance runs, I have to evaluate some numbers of, like, say, how much of CPU is required, how much of GPU is required, how much RAM they might take. So all these details I need to evaluate. So based on that information only, I will tell to the block whenever it is starting, right? Hey, block, you require this much of RAM is what I'm going to tell. So that evaluation I have not done it, but I'm giving some approximated numbers to show a demo. So those data are collected here, and then it will create a requirement. So let us see this function. Yeah. So basically here, basically I guess I'm taking something from the parameter. So for this resource allocation policy, I'm sending some parameters. With that parameters, I'm trying to check how much of minimum CPU is required, how much of memory is required, how much of GPU RAM is required, and how much of minimum storage is required. Storage is also important, because if the models are too heavy, you need to have a minimum storage required. Let's say you have a DeepSeek model which is like from 100, 200, 300 GBs. So if you don't have a storage, then that's also a problem. So a storage is also considered here. So right now this is dummy. It just, like, if memory is more than 0, it just makes 1. So I'm not going to use this variable. So let us see the this is the requirement has on some key CPU, memory, GPU, and all. So that I got the requirements. Next I have a current placement. So I need to know which machine I am in, which GPU I am in. So for that reason I'm calling this function to understand where is my current placement, so that again I don't have to assign to the same node, or same node and same GPUs. So in the current, so it's basically whatever the metrics are there, right? I'm iterating to the blocks matrix. So in the blocks metric, I'll get each instances, and in each instances I'm checking whether the instance ID is this particular ID or not. This is the ID of a failed node. So if it is not, because in the block matrix, let's say you have 3 4 instances, you will get the metrics of each and every instances. So basically you are in the block metric, you will know which machine it is located as well. So that's what my intention is. So once you got a clear hit, then you are taking a node ID, and right now node key is of no use, so I'm just keeping on one more variable. So node ID is what my interest is right now. So I'm trying to control my reassignment not to the same node. So this is the current placement. So once I got the requirement and current placement, let me see the what all available nodes are there. So let me get the get available nodes, where I'm passing cluster matrix, and healthy nodes. This healthy nodes is given by the AIOS itself. If some nodes are not available, or some nodes are down by because of some reason, so you will not get in a healthy nodes list. So yeah, so the get available nodes. So here cluster matrix, healthy nodes are passed. So you are trying to from the cluster you will try to get all the nodes detail, and node data is one other key. Nodes here is a dictionary, and nodes data is the array. So I needed that nodes data, and also I needed the metrics. So I'm trying to get the node metrics of all the nodes. So now I'm just creating one more variable here. Basically I need node ID versus metrics is what I wanted. So I just created one more variable. So now I'm iterating each and every node. In that, if this node ID, basically the ID of the node is not in a healthy node, I'm trying to skip that node, because those are, like, I'm saying that node is not available. So that's why I'm doing a continue operation. So now I have a matrix from the node, and then I'll calculate whether CPU, I'll get the CPU informations of the node. So how many total CPUs are there in the node? So that I'll get from the node details, not from the node matrix. How many total CPUs are there? And what is the load right now? So that I'll get from the node matrix. So for that node, I'm taking a load 1m. Basically, it's 1 minute's load average. So you can change this maybe to a 5 minute load average or 15 minute load average also. You can change it. But for time being, for the demo sake, I'll just keeping load average 1 minute. So this is the CPU load, and I'm trying to get total, basically how much CPU is available is what I'm trying to calculate here. So total CPU minus load of the CPU will give me the available CPU. So with that, I'll calculate the utilization. So CPU load divided by total CPU, I'll get the CPU util. Similarly, I'll calculate for the memory as well, and similarly I'll calculate for the GPU also. So get the GPU matrix. So right now you can complicate these things using the GPU matrix. So like GPU utilization, with the help of GPU utilization, whether the GPU of this machine is free or not, that kind of things also you can basically do that. So here I'm just giving model name, free memory, total memory kind of informations are created here. Then calculate total memory, GPU memory matrix. So what I'm trying to do is, let's say a model requires, let's say, some 50 GB. Let's say I have some 3-4 GPUs in a node. Whether the free available GPU is 50 GB or not is what I'm trying to get the numbers. So once I got that GPU matrix, I'm just dumping in here. So this is basically a complete nodes information. So what all it is having: total CPUs, available CPUs, CPU utilization, total memory, available memory, memory utilization, total GPUs, and each GPU's information, GPU matrix, individual GPU matrix. It is a overall nodes matrix, and this is individual GPUs matrix, and raw node data, and the node data as such, raw data whatever we got, and raw matrix. So basically those are nothing but whatever we collected here from the directly from the this variables. So those also is put, and that we call it as node info, and that we added into the available nodes, and we have returned that back. So now, so we got the available nodes. Basically we removed the nodes which are not healthy, and rest all nodes we collected it. And once we got the GPU details, sorry, node details, what we are doing now, for reassignment, exclude current node if possible. So this is again, it's up to you. Right now I want to avoid that node, because I don't since that node is messy, or because of some reason the instance is not loading, I just want to avoid that node. So if current placement and length of all available node is greater than 1, then fine. If not, I'm just assigning all available nodes to available nodes. So here current node ID is nothing but current placement get node ID. You will get the current node ID, and I'm just iterating if node ID, all the available all available nodes, if node ID is not equal to current node ID, which is current placements of the instance, such I'm avoiding it. Rest all I'm dumping in available nodes. Now this is becomes the available nodes. So if available nodes is empty, I will raise, hey, no suitable nodes are available. So for the reassignment, the error message, I'll raise it to the caller. So the resource allocator will basically call this message, and it will not do reassignment. So so here there is the final guy is this function. What it is responsible is whatever the available nodes are here, right? So with that information, it will try to, with the requirement information, it will try to calculate whether this model, this instance can be put in this machine or not. So we'll see what all it does. Yeah. So we got the like GPU eligible nodes. So first of all, I'm trying to calculate what all nodes are there which are eligible by because of GPU RAM. So right now not consider the utilization, so that you can include it to make it things a little bit better. So with this available nodes versus requirement, I'm passing to this function. This function will tell me out of, let's say, n number of nodes, what all nodes are eligible by just because of GPU RAM. So those nodes I will get here, and those nodes, if those nodes are not available, I'm raising an exception saying that no sufficient GPU RAM is GPU memory for a requirement is available. So let's say now only these nodes are available for a by GPU memory, because I'm giving a first priority to GPU memory. You can do all this parallelly also, then you can aggregate as well, you can do AND operation. Right now I'm not doing that, I'm doing one by one. So now once the GPU eligible nodes are available with you, then I'll calculate the CPU memory. That is also like a scarce resource. So I'll try to evaluate. I will evaluate whether the CPU RAM is sufficient for this model or not. So again, the similar approach, whatever the approach I'm taking here, right? I'll basically calculate. I have the each node's available RAM. So and also have the requirement. I'll check basically whether enough CPU is there, enough CPU RAM is there or not. So once that I'll got the in that, let's say one node is removed, rest all will be enough CPU RAM. Those nodes I'll collect. If not, again I'll raising the exception. Then it's related to a CPU vCPU availability. Again I have the requirements. If it is not available, I'll remove those nodes, and if it's available, whatever having the available vCPUs, those nodes I have here. If we don't have any eligible nodes because of CPU, again I'm raising an exception. Next, last preference is given to the storage. So if storage is not enough, then again I'm raising an exception. So based on that, I got the details of all the nodes now. Now I'm calculating some weights, because you have n number of nodes which are having good enough GPUs, good enough storage, good enough CPUs and CPU RAMs. Now I need to give a score to it. So before giving a score, I have one more variable known as weight. So I'm just giving this weight is also a variable, like, yeah, right now the by default value of the weight is 40% given to the GPU memory. So whomsoever is having more memory, they will get the more weights. So I'm just multiplying by 0.4. For CPU I'm giving 0.3, for CPU memory I'm giving 0.2, and storage I'm giving 0.1. So you can alter this, as this is a parameter, right? So you can send any numbers. So at the end, when you sum this up, it has to be 1. So with that weight, yeah. So with that weight, it is trying to it will try to calculate a score. That score is basically weight multiplied by the GPU space available. What is the total? Let's say what is the total space available for GPU RAM? What is the like total memory of the GPU RAM into that weight? A total CPU RAM into that weight. Total CPU into that weight, and total storage into that weight. So I'll do this for all the nodes available in the final nodes available. So from that I'll get a score. So for that score I'm trying to get the maximum, and x total of score is what the key. So basically this guy will return a array of dictionaries, where each dictionary is for each node, and it will have an x total score. So in that, the best one I'll choose, which is a best node, and in that this is the from that, if I take the node that is a selected node, so that becomes a node ID now. And uh, though that once I select that particular node, it might have multiple GPUs also. So in that also I need to choose. Let's say 8 GPUs are there, but in that only 4 GPUs are good enough. So for me, I need to select maybe best 2 GPUs, right? So because of my requirement, because my requirement, let's say it requires 24 GB of RAM. So if you have a 16 GB2 model, like Tesla T4 cards, so you need to choose those T4 cards. So that I am choosing it. Right now again I'm going with just the memory, so you can take care with the help of you can complicate this, or you can along with the RAM you can add your GPU utilization also into consideration. So right now at the end I'll get the allocatable GPU. So that's what I'm returning here, node ID and GPUs. So from that I got the allocation details, so which is like node ID and GPUs. So that's what this function is returning. And since this is a resource allocator, and in the resource allocator I'm doing an uh, reassignment. So reassignment has to pass a node ID and GPUs available. So this is the whole reassignment. So similarly you can add your functions for each and every functions here. Allocation also we can do the same thing, basically like same as the handle reassignment is there, right? Similar copy least you can do it here as well. So what all parameters are passed? This is like minimum CPU per instance. So what is the minimum CPU requirement is there for by CPU? What is the minimum memory is required for this instance? What is the minimum GPU memory is required for the instance? What is minimum storage is required? This I am not using it. So node threshold also you can provide. So yeah, this is one important. Let's say a node is having a RAM, but it is already reaching some thresholds. Let's say some memory threshold or a storage threshold. Some threshold is also it's meeting. So then I'm trying to check them out. So nodes which are going beyond this 80% utilization in storage, 80% utilization in memory, right? I'm not going to use them. So instead of saying not going to use them, you give a lower weight for them. That also you can do it. So this is the policy that we have written for a demo sake for a resource allocators reassignment. So again, you upload this file, upload the zip file and register the JSON. And next, let us create the blocks. So for creating the blocks, you need to register the component first. And what is component? It is just like it will provide the schema for the blocks, input, output, or parameter settings, management functions, all those things. It will provide a schema, and also it will have extra metadata like what is this model, whether it is trained on what all data set like MMLU or something like that. All those informations will be available in this registration file. So I have already registered it, so I will not go and register again. But now let's see the deployment of the block. So one important thing is right now in this deployment, right? So let me just show you the deployment file. So it is in part 2 and the demo block allocation. Yeah, so this is the mode allocate and demo block ID. This is the block ID that I'm going to deploy uh, and this is the component URI that I'm choosing from, and here is init settings, init parameters. So these all are fine. So block init data, init settings, those all are fine. I'm not going to talk about that. What is interesting for me is the policy rule. So they have some policies like say one is cluster allocator. What is this cluster allocator policy is mainly for selecting the cluster, in which cluster, like say when you are deploying for the first time, right, the block, if you are not giving the cluster that you want, it will go and sit in some other cluster. So to select the cluster, you require the cluster allocator policy. So you can write you can straight away give the filters here. You can give the query, let's say I'm directly giving, hey, I need to deploy in this cluster only, not in any other cluster, is what I'm trying to hard code. But you can write a better filters. So whichever let's say like cluster where more GPUs are there, cluster where more CPUs are there, something like that. A complex query also you can write. So we have some other videos for this cluster allocator and all. So this the first is a cluster allocator, second is a resource allocator. So this is what we were I was showing you the code. So here I am using a demo block resource allocator stable. This is the resource allocator that I created. I just showed you a few minutes back. Resource allocator, and this was the code that I showed you. So before that, JSON file I'm looking at. Okay, so yeah, so this was the demo block resource allocator. So this is the JSON that I'm using. So now in the resource allocator, the parameters that I am giving, right? So this is the since this resource allocator right now I have written bit generic, but little more complications we can add there. So since it's a generic, so I'm giving these numbers with respect to this particular block only. So for your block, these numbers will vary for sure. So I'm giving minimum CPU, for instance 5. I don't know the exact requirement of this model, but I'm just giving this numbers. So minimum memory per instance, so 3 GB is what I'm trying to give, but minimum GPU memory for instance, GPU memory I require, I know this number somewhere, like I have run several times, I have calculated this. So 26 GB around memory is required for the magistral model, and minimum storage required 26 GB. The file size of the model is also around this much, and also I'm giving some thresholds like 888.8 80% utilization should be there. So this all are fine. Weight is again, yeah, 40, 30 to 20 and 10%. So this is my resource allocator. Similar to the resource allocator, we have several other policies also. I'll just show you one other policy, load balancer. This is basically policy which will, like say if more hits are coming and you have multiple instances, to which hit has to go to, I mean which input has to go to which instance. So to decide that, you have a load balancer. So again, we have a separate video for load balancer also. And next is a stability checker. This is what the health checker policy that we have written. So this is the policy. So here basically failure threshold I have given 5. So meaning once an instance is observed to be failing, and once it fails 5 times, then only we'll go for a reassignment. So here I have given some parameters that is needed, because this policy will hit the reassignment policy, right? So it requires a gateway URL. So that's why I'm giving those gateway URL. And the last policy being is autoscaler. So what is the autoscaler? Like more number of hits are coming, the more block has to scale. It has to create more instances to take care of the number of hits coming. So that's why the autoscaler is decided. Again, autoscaler decides whether whether the scaling is required or scale down is required, scale up is required. Those kind of decisions are taken by this autoscaler. So you have to write its own policy. So now we saw that this particular JSON. So it's from part 2 demo block allocation demo master JSON. So now before starting this block, let me try to show you certain kubectl commands. So to get the namespace, since I'm running in my demo cluster, I'm going inside the demo cluster master node, and I'm trying to get all the namespaces. Here, as you can see, there is a blocks namespace and there is a controller namespace. Controller is where the cluster controllers components are present, and inference server is where inference server are present, and rest all are Kubernetes internal things. And this is a VDAX. Like if you create a VDAG, it will go in this namespace. Matrix is a cluster controller, similar to cluster controller. Matrix is one other namespace where metrics related to cluster will set. So our interest is block, because whenever we create a block now, blocks namespace is what we need to check. So this is what to all the get the parts of the block. So let me just put it in watch, so that whenever I deploy a block, I should see a some parts details there. So now when you see a block, right? So when block starts, it will create two pods basically at the initial time. So what are those pods? One pod is having some 6 containers. One is health, one is proxy, block executor, Redis container, and a mapper, and these are the 5 blocks. One more block might be there, so I just missed it. So there will be some containers. So these containers are responsible for doing their task. Like this health guy will be doing a stability checking. This mapper is basically a service where whenever a new instance are created, right, this mapper will have those details. So this mapping will be provided for all other subcomponents of the block. So you have to check the blocks architecture, like how the block architecture is. So there is a mapper, there is a executor. This executor is basically for load balancing. So several such containers will come here. And the other pod being, so this is from one pod, and other pod being the instance pod. Let's say whenever you create new instances, you will have new pods for it. So and in the each pod you will have two containers. One is instance and one is a Redis. So Redis is basically the internal queue. Let's say the load balancer, whenever it gives a task to one particular instance, right, it will put to the Redis of the that particular pod, I mean that particular instance. So this instance will read it from the Redis, and it will do the processing, and it will send it back to the Redis. So that's why the two pods will be created, and one pod is for a other subcomponents of the block, and one more pod is for an instance. If you have more instance, it will have more pods. And one other important thing is, I just want to show you this again in a master node. You need to check this in master node again. The These all are in the controllers namespace, and here there is one infra component. So what is this infra component? It is from the again cluster controller, where it will talk to the Kubernetes cluster to create the any pods required, whether it could be a VDAC controllers pod or whether it could be a blocks pod. So so any infra Kubernetes stuffs it requires, right? So then that is a pod. So why I am checking it? Because whenever block is creating, this infra guy will create the pods, and whenever reassignment happens, then also this guy only creates it. So let us check the log of this file first. So before to get that, I have to get all the pods of this controller namespace. Yes, so this is the controller of this controller has the infra container. There are 6 containers, right? So let me just take the um, infra container from here. Let me just do log. Yes, so we got the log now. This is fine. This is something else. So now let us create the block. So let me deploy the block now. Yes, the block is created. Let us see here. Yes, the container is creating. So let me take this pod and let's check the health of that. Health container, I'm checking the logs. And yes, the logs is coming. This I have planned such that this model is running in a machine where RAM is not sufficient. It requires somewhere around 26 GB, but only 23 GB RAM is available. So this block is not getting started at all. I'll show you that. So this is the health pod. Let us see what the health pod does. And also important thing is I just want to show one more pod. First, so let me take this controller. Okay. So this is the infra pod. So let us see when reassignment happens, something will happen in the infra pod. And also, yeah, now, yes, so the health instance is doing its activity, which is nothing but basically checking the log of the instance health. So the failure count is 1 right now. So we need to wait until the failure count reaches 5. So this might take some time. So let's pause here. And I'll just show you what is the message that model is giving. So this is the instance and this is the Redis instance. So Redis container. So let me check the log of this using Gridtail. Yes, so it's basically complaining about the CUDA buffer size. So it is not sufficient enough. So that's why it has gone out of memory and the model is not loading. So let me show you the LMS. Yes, now the failure count has gone to the third one. So we need to wait for some more seconds. So once it reaches 5 or 6, so more than 5, right? So when it reaches 6, it has to call the reassignment policy by itself. So I'll go to put NVIDIA LMS in all the nodes so that let us see which node it get deployed. So we can use the Kubernetes dashboard as well, but I have not deployed the Kubernetes dashboard in the cluster as it is a demo cluster. Yeah, the failure count is 5 now. Let's wait for the sixth one. So basically, AIOS is polling each and every instance whether you need to provide the health endpoint in our code. So there is one separate function that you need to write, which is health function. If it returns status healthy, then basically AIOS will poll the each and every instance once in a while. So if they return status unhealthy, then uh, that only is taken and given to the our code. So you need to implement how the block is status healthy is, or it's unhealthy. You need to implement that function in your code. So right now in my model, I have implemented that. So that's why since it is not since the model is not created properly, it is creating an it is returning always unhealthy. So that's why the AI was able to pick it. Yes, now I guess the call would have gone to the yes, the infra, it has gone to the infra. The resource allocator will basically will run in infra. So what it has done is it has in its identification, right? So there are this is the requirement that I have given in my parameters, and available nodes are 3, and in that now GPU memory eligible nodes are 2, because the first one where it is deployed is not usable at all. And then we have a worker node 2. Totally at the end, CPU memory eligible nodes are 2, and also CPU eligible nodes are 2, memory eligible nodes are 2, and storage eligible nodes are also 2. So at the end, you have these two nodes, 2 and 4, and this is the final score with respect to available nodes and RAMs. So in that, it has chosen highest one, which is demo node, GP node 2. So let us see the GP node 2. So now the pod got evicted from that node where it was not running because reassignment is happening, right? Yeah, now the reassignment has happened. So now the model is loaded. Let us do an inference. So you want to know the details of the block or anything, so you can always use this endpoint, which I have already shown. And the inference server is already created in the previous video itself. So I'll use that inference server and let me do an inference. So this inference might take some time. So as you can see, there is an utilizations going here and there. So the inference is happening in the node where it got reassigned. And to show you the healthy status. So right now, yeah, the health status is coming healthy. So that's why it is not triggering any unhealthy events, or it is not triggering any call for an reassignment. So the inference is going on. Yes, the inference would have been done now. So it has returned some response. I'm not so interested in the response. And to understand the block metrics, you can always use this block, the either global block metrics also you can use, or else you can use the gateway URL as well. So I'm using a block metrics here to understand the metrics of the block. So to understand the structure of the metrics content and all, we have a separate video for that. And once the the blocks are done, if you don't want it, so you can always clean up, so you can remove the block. So let me run this command. Yes, the action is performed. So let us see. Always whenever the pod is getting created or deleted, so it has to come to the infra block for sure. the pods are removed. So yeah, the memory is free now. So yes, this is about the second part where we have shown bit of policies. One policy for add node, and similarly you can write for other policies as well. And these policies are at gateway controller, gateway as well as a cluster controller where cluster admin can write it. And also we shown two more policies of a block, which is a health or a stability checking, and then is about the resource allocations, reassignment action. So that's it for the video. I hope you got to know how to create policies, how to deploy those policies for controllers and gateway, and also how to create a policies for a block as well. So that's it. Thank you.